Hi everyone, and welcome to our bone structure lab. So in this lab, what we're going to be doing is we're going to be looking at bones and determining which area or which grouping they belong in. We're going to look at bones and try to figure out why they are as strong as they are. And we're going to, if we have a chance, we're going to look at an actual femur bone from a cow. So we'll see if I can get into that one as well and get that one worked. So in this first section right here, what you're supposed to do is go through and read in your book about the different categories of bones. So we have long bones, short bones, fat bones. It is a Monday. Long bones, short bones, flat bones, and irregular bones. And then we also have these special bones called sesamoid bones, which in last week's lab I talked about. So I'm going to show you an example of each type of bone, just so that you have them here. So this is the femur bone. You guys can see it right here. This is considered a long bone. Long bones are longer in length. So let me just write long. Have a long length. And not a very big width. And so that's how we identify long bones from other bones. Long bones are probably the most common bones of the body. Then we have short bones. So short bones are, and here's an example of a short bone, one single short bone, right there. This is actually the Epiphyseal bone. It's a carpal bone. So when you look at all of your carpal bones here, these are all short bones. Short bones have similar length and width. And if I could spell similar, it'd be great, right? AR. Okay, so that's a W-I-D. That's just a T, sorry. So let me write it here. I-D-T-H. It looks really messy there. So carpals and tarsals tend to be short bones. Then we have flat bones. And flat bones are just like they sound. They're flat. So this is the scapula. The scapula is a flat bone. They're very, very thin. And they have a similar makeup to your short bones. So your skull cap is composed of flat bones. They tend to also have a slight curve to them. Irregular bones. Irregular bones are uniquely shaped. So this is an irregular bone. It's very weirdly shaped. Another example, our famous Ethmoid Bone. This is an irregularly shaped bone. So I'll hold it like that. This is the bone that comes from the skull and into the nasal cavity. Irregularly shaped. Okay. So irregular bones are unique. Have a unique shape. And then the sesamoid bones. These are typically short bones that have been produced in lines of stress. And so our famous example is our patella. I'm just going to write special here because I don't have room, but they're the special bones that form in lines of stress, okay? So over here, I want you to use your notes, look at your previous lab, and identify each of these bones as a long bone, short bone, flat bone, irregular bone, or sesamoid bone. And then at your table, so you're supposed to find 2 bones of each type. So what I'm going to do is I'm going to hold up bones for you to look at, okay? So the first bone I'm going to give you is this. This is a coxal bone composed of 3 different bones. Remember, ilium, ischium, and pubis. But the coxal bone itself, the whole thing, is what type of a bone? So that's your first one. So I'll give you a second, and now I'm going to go to the next one. If I'm not giving you long enough, guess what? You can pause this. Super sweet. Here's the next bone. So what bone is this? This is the ulna. Whoa, it just fell. What type of bone is the ulna? This is a clavicle. What type of bone is a clavicle? This is the patella. What type of bone is the patella? Oh, not that side. All right. This is the trapezium right here, this bone here. What type of bone is the trapezium? This is the scapula. What type of bone is the scapula? Sternum. What type of bone is the sternum? Let's see. Oh, no, I did that. Let's do pisiform. What type of bone is the pisiform? And cervical vertebrae. What type of bone is cervical vertebrae? That should give you every single box filled except for one of your sesamoids, because we only have one special sesamoid bone. Okay. All right, so now let's look at page 2 of this activity. So page 2 is about the structure. Oh no, I'm lying. Let's go to page 3. So let's just go right through this one, okay? Let's go to page 3. All right, so now we're looking at the structure of bone. So at this point, you should have watched my videos over chapter 6. So you should know the difference between your inorganic and organic materials of bone. And hopefully you know what makes bone strong, hard, and what makes bone slightly flexible. So what we did was, and by we I mean what I did, over the last 2 weeks I have soaked bones in a hydrochloric acid / vinegar mixture. And so I want to show you this. So this is the bone. And do you see how I'm bending it here? It's like bendable. Maybe this one will even be easier to see. See how I can bend? I'm like legit, I don't know. Oh, I guess I'm going the wrong way. Sorry. See how that's bending? Now you can see it, I think. So this is bending, making the bone soft. What in bone makes bones hard. So when you look at this, it says, what do you notice about the bones that are overbaked? So here's an overbaked bone. What do you notice about the bones that have been soaked? So that's what I just showed you here. These are the soaked bones. So now let's look at the overbaked bones. Here's an overbaked bone. This bone has been baked and baked and baked, okay? And I want to show you. Oh, that was super simple. Did you see how brittle that bone was? Just snapped. Super simple. So why do you think that the bones that were overbaked are so brittle? And why do you think the bones that were soaked for that 2-week period are so soft? Basically, what I'm asking is, what has been taken out of the bones or been damaged from the bones that causes them normally to be hard and flexible? And so another way to ask that is, what quality of bones do bones have that keep them from being brittle? What quality do bones have that keep them from being soft? Hey everyone, welcome back. So I have with me this beautiful femur. So this is a cow femur. Actually, I believe Christy Boggs was able to get it, and it's been in our freezer for a while. So this is one half of the femur, and let me just pull this over so you can see there's the other half. So it goes like this. So you can see the bone has been cut, a sagittal section down the femur, okay? So what we can see on the femur, we can see right here. Do you see this structure? So this is a very frozen femur, but you can see right there, this is a ball here. This is maybe this is a better picture. So here you can see that ball even better right here. So this is the ball of the femur. And then you can see the length running down on the femur here. Okay. So up here we have so it's kind of the part up here by where the ball of the femur is. This would be called the proximal epiphysis. So the epiphyseal, or I won't say that, the epiphyses of the bone are the ends of the bone. And so the proximal epiphysis is the epiphysis closest to the torso. The distal epiphysis then would be the one farthest away from the torso. So we have that. We also have, because this is cut in half, you can see right in here, this is all bone marrow. So this is yellow bone marrow, which is found in the medullary cavity of the bone. So yellow bone marrow is what we find in adults. In infants and children, we would have red bone marrow in this area. And in adults that are very ill, they also might have red bone marrow. Typically, the red bone marrow in adults then is found in the spongy bone. It's really hard to see because these are just frozen. I mean, they've been frozen. I just took them out. I should have thought about this and took them out at 7:30 today, but I still think it would have been kind of frozen. You can kind of see where you're going to see some openings coming. So this area here is all spongy bone. Typically the area, like the head, is going to have some spongy bone in it. But the diaphysis, the length of the bone, is going to be all compact, so very thick. And you can see how smooth that bone right there is. That's diaphysis bone, okay? So, and let me pull this one because I feel like this one you can see better. So, do you see how there's like little holes? That's spongy bone there. But then again, this part here, you can see along the edges, that's compact bone, okay? So in spongy bone is where we find our red bone marrow. And we typically see red bone marrow in irregular shaped bones, flat bones, and the ends of our femur is where we're going to find the red bone marrow in adults. What else am I looking for? The periosteum. So the periosteum is a tissue that surrounds the bone. So on here, do you see that little red tissue right there? That would be part of that periosteum. The periosteum is a connective tissue, dense irregular connective tissue that attaches and it feeds the bone. So nerves, blood vessels can move into the bone from there. And then one other structure that I always point out is the epiphyseal plate. On here, it's hard to see again. So the epiphyseal line is probably easier to see on here. I'm looking to see. So do you see this little line right there? That would be like where the epiphyseal line is. Let me see if I can, I'm going to take my gloves off for a second. And I'm going to go to small. There we go. And it's still recording. That's wonderful. So right here, you can see that epiphyseal line. Whereas if this was a child, an infant's bones, it would be a big, thick plate of cartilage, okay? And that would be hyaline cartilage. On the end of these bones, we have articular cartilage. So articular cartilage is also hyaline cartilage found at the ends of our bones that allows our bones to move without friction. I'm looking at everything up there and I'm thinking, and then again, you can see that periosteum right here. So I think you should be able to label everything on here now very easily. But if you do have questions, definitely ask. The last part of this lab then is just answering these 4 questions. You may have to use your textbook or the PowerPoints, but that's fine. Use them, answer the questions, and then you'll be able to turn this in next week, okay? All right. I hope that you were able to get through this lab, and I hope you enjoyed it. It was way more fun if you were here because you can physically touch the bones and bend them and break them, and that's always fun. All right. I will talk to you later. Bye.